So there are two ways we can implement the stack. Either we can use one array or we can use one linked list. So in this video we're gonna see how we can implement the stack using one array. So first of all we have to define the array. So here is one integer array with the specified size. That means we have created one array with a specific size. Like an example, suppose the array has the size of 5 and the array indexing starts from 0. So the first element will have the index 0, then 1, 2, 3 and 4. Now we're gonna use this array to implement the stack. So for better understanding, let's now rotate our array. So we're gonna rotate our array like this. Now this looks like one vertical container, and also we're using one top pointer which will initially point to -1. That means we are using one top pointer which is pointing to -1. So the top pointer is pointing outside of our array, which signifies that our array is initially empty. Now we can define all the different array operations, like we can define the push, pop, pick, isEmpty, isFull and so on. So first of all, let's just define the push operation. So here is the function to perform the push operation. So here we're gonna pass the value that we wanted to add into our stack. So first of all, we're gonna check whether our stack is full or not. So if our top pointer is pointing to max -1, max is the size of our array. So if the top pointer is pointing to this max -1, that means our stack is full. So in that case, we're gonna simply print stack overflow and we're gonna return, because we cannot push when our stack is full. Otherwise, if the stack is not full, in that case, first of all we're gonna increase the top. That means the top will be pointing to this 0th index, and in that index we're gonna store our value. Suppose we are calling the function push1. That means this value 1 will be pushed in this 0th index, and then we're gonna print the item is pushed to the stack. So this way we can push another item like push2. So that means first of all it will check whether the stack is full or not, and then the top pointer will be pointing to the next index, and then our value 2 will be pushed in that index. So this way we can push multiple items in our stack on top of the previous value. So let's now define the pop operation. So the pop operation is opposite of the push. So using the pop operation we can remove element from the top of the stack. So here is the function to perform the pop operation. So first of all we're gonna check stack is empty or not. So if the top is pointing to -1, that means if the top is pointing to -1, that means our stack empty. So in that case we're gonna print stack underflow or stack empty and we can return. Otherwise, if the stack is not empty, the top is pointing to a different index in the stack, so in that case we're gonna return stack top --. That means we're gonna return this top element from our stack, and then we're gonna reduce the top pointer to point to the previous element, and you can see our topmost element is removed from the stack. So that means if we call pop, the 3 will be removed because it was in the top of our stack. Similarly, if we call again the pop, then this time the value 2 will be removed from the stack and the top pointer will point to the previous element, and this way it will continue until our stack is empty. So let's now define the pick operation. So the pick operation will return the topmost value from our stack and it will not remove the top value. So here is the function for the pick operation. So in the function, first of all we're gonna check if our stack is empty or not. So if the top pointer is pointing to -1, that means our stack is empty. So in that case we're gonna print stack is empty and then we're gonna return. Otherwise, if the stack is not empty, in that case we're gonna return the stack top element. So here the top pointer is pointing to the element 3. That means this element 3 will be returned from the stack, but the item will not be removed from the stack. So the pick function will return the value from the top of the stack without removing it. And also we have the isFull function. So this function used to check whether our stack is full or not. So here we're gonna check if the top is max minus 1. Max is the size of our stack. So if the top pointer is pointing to max minus 1, that means our stack is full. And similarly also we have the isEmpty function. So this is the opposite of the isFull. Here we check if the stack is empty or not. If the top is pointing to minus 1, that means if the top is pointing to this minus 1, that means we can say that our stack is empty. So this is the way we can use the array and we can implement all of the different stack operations. So when we implement our stack using the array, there are certain advantage and disadvantage. So the advantage is here we can fast access any memory location using the index of that location. So here we can simply access any index position by passing that index between the square brackets. And also here things are pretty simple because we don't have to use any pointers or anything as compared to the linked list. And thirdly, it uses less memory overhead. So here no extra memory is required because we do not have the pointers. And also there are certain disadvantages while using the array. So here we have the fixed size of the array. So we have to predefine the size of the array. We cannot increase later on in our program, which can lead to memory wastage or overflow. And secondly, no dynamic resizing. That means we cannot dynamically resize our array. So here once the stack is full, we cannot expand it. So these are the main drawbacks of using array. So in the next video, we're gonna see how we can implement our stack using the linked list. So hope you understand the concept. See you in the next one. Take care.